EMT, or electrical metallic tubing, is a common type of conduit used to protect electrical wiring. A key consideration when installing EMT is the number of wires you can safely and legally run through it. This is governed by electrical codes to prevent overheating and ensure safe operation. Let's examine a typical wire fill chart for EMT conduit. The chart specifies the maximum number of wires of a particular gauge that can be installed in a given size of conduit. The unit AWG stands for American wire gauge, which is a standardized system for denoting wire size. A smaller AWG number indicates a larger wire diameter. For example, 12 AWG wire is larger than 14 AWG wire. The chart lists conduit sizes in inches, such as 1/2 inch, 3/4 inch, 1 inch, 1-1/4 inch, 1-1/2 inch, 2 inch, 2-1/2 inch, 3 inch, 3-1/2 inch, and 4 inch. The most common sizes for residential wiring are 1/2 inch and 3/4 inch. The chart then provides the maximum number of 14 AWG wires and 12 AWG wires that can be installed in each conduit size. For instance, a 1/2 inch conduit can hold a maximum of 5 14 AWG wires or 3 12 AWG wires. A 3/4 inch conduit can hold 10 14 AWG wires or 6 12 AWG wires. A 1 inch conduit can hold 18 14 AWG wires or 10 12 AWG wires. A 1-1/4 inch conduit can hold 26 14 AWG wires or 14 12 AWG wires. A 1-1/2 inch conduit can hold 35 14 AWG wires or 19 12 AWG wires. A 2 inch conduit can hold 53 14 AWG wires or 29 12 AWG wires. A 2-1/2 inch conduit can hold 76 14 AWG wires or 41 12 AWG wires. A 3 inch conduit can hold 104 14 AWG wires or 57 12 AWG wires. A 3-1/2 inch conduit can hold 136 14 AWG wires or 74 12 AWG wires. Finally, a 4 inch conduit can hold 176 14 AWG wires or 96 12 AWG wires. Keep in mind that these numbers are based on the assumption that the wires are stranded and not tightly packed. Stranded wire is more flexible and easier to pull than solid wire. The actual wire capacity may vary depending on the specific wire insulation type and the ambient temperature. Different types of insulation have different heat dissipation properties, which can affect the maximum allowable wire fill. Higher ambient temperatures can also reduce the allowable wire fill. It is generally recommended to leave some room inside the conduit for air circulation. This helps to prevent overheating and makes it easier to pull wires. Overfilling a conduit can make it difficult to pull wires, which can damage the insulation and create a safety hazard. It is extremely important to always consult local electrical codes for specific requirements. Electrical codes vary by jurisdiction and may have more restrictive requirements than the general guidelines. For example, the National Electrical Code, or NEC, specifies the allowable wire fill for different types of conduit in Article 344. Always refer to the latest edition of the NEC and any local amendments. Factors that affect conduit fill calculations include the size and number of conductors, the type of insulation, and the conduit size. To accurately determine the allowable wire fill, you may need to perform calculations based on the cross-sectional area of the wires and the conduit. Electrical codes typically provide tables and formulas for calculating wire fill. When running multiple circuits in the same conduit, it is important to consider the directing factors for conductors. Directing factors reduce the allowable ampacity of conductors when multiple current-carrying conductors are bundled together. This is because the heat generated by the conductors can increase the temperature inside the conduit, potentially leading to overheating and insulation damage. The NEC provides tables for directing conductors based on the number of current-carrying conductors in a raceway. When determining the appropriate conduit size, it is also important to consider future needs. If you anticipate adding more circuits in the future, it may be wise to install a larger conduit than is currently required. This will provide flexibility for future expansion and avoid the need to replace the conduit later. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it is best to hire a licensed electrician. Always follow all applicable safety precautions when working with electricity. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and energizing circuits before working on them. When pulling wires through conduit, it is important to use a wire pulling lubricant. This will reduce friction and make it easier to pull the wires without damaging the insulation. There are many different types of wire pulling lubricants available, so choose one that is appropriate for the type of wire and conduit you are using. When making bends in conduit, it is important to use the proper tools and techniques. Improperly bent conduit can be difficult to pull wires through and can also weaken the conduit. There are special conduit benders available that make it easy to create accurate and consistent bends. When connecting conduit to electrical boxes and other equipment, it is important to use the correct fitting. There are different types of fittings available for different types of conduit and equipment. Using the wrong fitting can create a loose connection, which can be a safety hazard. Always ensure that all conduit connections are tight and secure. Loose connections can cause arcing and overheating, which can lead to fires. When installing conduit in wet locations, it is important to use watertight fittings and seals. This will prevent water from entering the conduit and damaging the wires. Water can also cause corrosion, which can weaken the conduit and create a safety hazard. Always follow the manufacturer's instructions when installing conduit and fittings. This will ensure that the installation is done correctly and safely. If you have any questions about conduit installation, consult a qualified electrician. They can provide expert advice and ensure that the installation meets all applicable codes and standards. Remember that proper conduit installation is essential for the safety and reliability of electrical systems. By following the guidelines and recommendations outlined in this video, you can ensure that your conduit installations are safe, efficient, and code compliant. Firstly, always de-energize the circuit before working on any electrical components. Secondly, wear appropriate personal protective equipment, including safety glasses and gloves. Thirdly, use the correct tools and materials for the job. Fourthly, follow all applicable electrical codes and standards. Fifthly, inspect your work carefully to ensure that it is done correctly. Sixthly, test the circuit after completing the work to ensure that it is functioning properly. Seventhly, if you are not comfortable working with electricity, hire a qualified electrician. Eighthly, never work on live electrical circuits. Ninthly, always double-check your work before energizing a circuit. Tenthly, keep your work area clean and organized. These steps are vital for ensuring a safe and effective electrical installation.